Okay, let's now try a definite integral. We are supposed to integrate this when fx is given to us as this. And for this integral, it is actually not that easy to integrate, so what I'm going to try to do is to expand this using the a plus b square. So expanding a plus b square will be a square, so that will be sine square of 2mx plus 2ab, so it will be 2 sine 2mx sine 2nx plus b square, so it will be plus sine square 2nx dx. And the way that I'm going to continue with my integration is to break this up into three parts. The first part will be this, second, and the third part. As for this, we are going to apply trigonometric identity, the double angle formula. So this will be integration from 0 to pi. Applying the double angle formula for this, it will be 1 minus cosine of 2 times of this angle, which will be 4mx divided by 2 dx, plus 2 times of the integration of this from 0 to pi of sine 2mx sine 2nx dx, which we have already integrated this in part 1, so I'm going to make use of this result later on. Then plus integration from 0 to pi of this, and I'm going to try to make use of the same trigonometric identity, which will give me a 1 minus cosine of 2 times of this angle, which is 4nx divided by 2 dx. Let's integrate this. Half, I'm going to factorize it out, and integrating this that we have 1, it will be x, and cosine this, it will become sine of this, and since 4m is the coefficient of x, we will divide this by 4m, and the definite integral is from 0 to pi. And I'm going to replace this by the integral by the result that we have in the first part of the question. So 2 times 1/4 is going to give me a half. And for what we have here, it is going to be a sine of 2 times of m minus nx divided by m minus n, minus away sine of 2 times of m plus n x divided by m plus n. And again, this is from 0 to pi. And similarly for this, we are going to factorize out half, and integrating this is going to give me an x, and integrating this is going to be minus sine of 4nx divided by the coefficient of x, which is 4n, and this is going to be from 0 to pi. Let's do the substitution. So this is going to be half. If I were to plug this in, this is going to be equal to pi. And now what we have here is a sine of 4m pi. 4m, m, it is given to us as an integer. In fact, m and n, they are all integer. So what we have is a sine of an integer multiple of pi. Sine of an integer multiple of pi is always going to be 0. So this, when I substitute pi in, it is going to be 0. So this whole thing is just going to be pi. And now I'm going to substitute 0 in. It is definitely 0 here and 0 here. So it will be pi minus 0. Plus here we will have a half. Substituting pi in, we will once again have 2m minus n, which is going to be an integer value, integer multiple of pi. So this will be 0. And this, when I plug it in, it will be also sine of an integer multiple of pi. So it will be 0, which means that substituting pi in, it is going to give me a 0. The same goes for 0. When I substitute in, it is going to be 0 and 0. So it will be this minus this. Then plus half of, substituting half pi in, it is going to be pi. Then substituting this into here, it will be sine of an integer multiple of pi, which is 0. And then that means this will be just pi. Then I substitute 0 in, this will be 0 and this will be 0. So here will be 0. Which means that what we are going to be left with is just a half pi. 0, 0, 0, half pi. So plus another half pi, then 0. Which means that the answer is like a very, very simple answer. It is just going to be equal to pi.